Chapter 9. Grouping. Section 1. Grouping and aggregation. When there are many things, people will be used to divide these things into several categories according to their attributes, and then investigate some aggregate information of each category. This operation is called grouping on structured data. The specific action of grouping is, divide the records in a data table into several small sets according to a field, and those with the same field values are divided into the same small set, which is called a grouped subset or a group, and then calculate some statistical values of each group of records to study the pattern of these data. For example, in the previously generated personnel table, we can calculate the average height and maximum weight by gender. The groups function can implement the above actions. Here, the multi-level parameters are also used. Before the semicolon is the field used for grouping, and here is sex. After the semicolon are the aggregate operations to be done. There are two of them, average height and maximum weight, separated by comma. The return value of the groups function is a table sequence, which takes the field used for grouping and the aggregate expressions as the data structure. Because the returned is a table sequence, the field names need to be set. Write them after each parameter of the groups function, separated by a colon. For the record sequence to be grouped, the number of records in the return table sequence depends on the number of values of the grouping field, and they are exactly the same. Because the data is generated randomly, the statistical values will change every time, and they are not in line with common sense. But it does not affect understanding. The aggregate operation in the second half of the groups function cannot be written casually. It can only support several aggregate functions made in advance. There are 5 common aggregate operations: sum, count, average, max, and mean. Writing these operations in the parameters is equivalent to executing the aggregate functions for these subsets. Aggregation can also be done for an expression. It is not necessarily to do grouping by field, but also by the result calculated by field. Group and aggregate the stock data and calculate the highest and lowest stock prices of all Mondays, Tuesdays through Fridays. The calculation results are 5 records, weekends have been excluded. For the grouping field or expression, we have a term called grouping key. We will understand why we use the word key when we've learned the later content. There can also be multiple grouping keys. A3 can calculate the average stock price on each weekday of each month. When there are multiple grouping expressions, the data table will be split in more detail, and the number of groups will roughly be the same as the product of the number of value types of these grouping keys. For example, this operation will divide into 12 times 5 is equal to 60 groups because there are 12 types of months and 5 types of weekdays, excluding weekends. The return table sequence has 60 records. However, this is not absolute. Because in this set of data, there are data on any weekday in any month, these 60 groups will all have corresponding aggregate data. Sometimes the data is incomplete, and some groups will no longer exist. For example, we do a sampling in A2, randomly getting 100 records and then observe the grouping results to see whether there are always 60 records in the return table sequence. We learned how to sample before. Please try it yourself. Because there may be multiple grouping keys, the groups function uses a higher level semicolon to separate the expression used for grouping keys and the expression used for aggregation in the parameters. Here you can experience the convenience of multi-level parameters. In fact, group aggregation can also be done without grouping key at all. This means that all members are divided into one set, that is, no splitting. For this whole set, calculate some aggregate values, and the return table sequence has only one record. However, this operation is not common because it can be done directly with aggregate functions. Similarly, group aggregation can also have no aggregate value part. A3 will calculate the months and weekdays when these stock transactions occur, that is, we only care about the groups that can be divided, not the aggregate value of each group. This is a common operation. It will calculate the possible values for grouping keys in a data table and list all the possible values without repetition. The database industry has a special name for this operation, which is called getting the distinct values. SPL also gives a function ID to calculate distinct. Different from the groups function that returns a table sequence, ID returns a sequence that has no data structure and no field name parameter. The ID function with multiple parameters does not calculate distinct for multiple grouping keys, but calculates multiple groups of distinct values respectively. If we want to calculate the distinct values for the combined multiple grouping keys, we need to use a sequence expression. You can observe the return results of A3, A4 and A5, especially the length of these return values. Again, it's easier to see the difference by sampling the data and then executing these codes. Now give us some Excel files, and we can already make various classification statistics on the data in them. For example, we have used this data for many times. It is very easy to calculate sales amount and order quantity by area or month. File.xls import at t can be simplified into a t function. Note that SPL is a case-sensitive language, and the field names should be written correctly. It's easy to calculate the companies that have done business with. Distinct lets us know that there are groups that do not need to be summarized. In fact, there are groups that should not be summarized. For example, in a group of people, we want to know who has the same birthday as others. It's very simple. After grouping by birthday, just see which groups have more than one member. However, the groups function will force a summary action, and we will lose those divided groups. Grouping is not always forced to summarize. Sometimes we are also interested in the subset after grouping. In fact, the word grouping has only the meaning of splitting in the dictionary, and does not continue to summarize. Because this operation was invented by SQL, and the set data type of SQL is relatively weak, it is unable to maintain the intermediate results of grouping, so a summary is forced. Over time, the whole industry felt that grouping must be accompanied by summary, and forgot the original intention of grouping. SPL restores this operation. The group function without S just group without summary. The S in the name of groups function means summary. Randomly generating the birthdays of 200 people, and then group by birthday. The group function returns the divided groups, that is, a sequence composed of some record sequences, which is equivalent to a two-layer sequence. Then, we just need to see which group has more than one member, and this is the syntax we have learned. Finally, concatenate these groups. Grouping without summary has practical business significance. Finding someone with the same birthday is just a game. Let's take another practical example. For the previous Excel file, we want to split it into multiple files according to the area field for different managers to deal with. It is reasonable to use grouping operation to split it, but obviously we can't summarize anymore. T function can also write a record sequence directly into an Excel file. After grouping by area, write each group into a corresponding file. A2.area is the abbreviation of A21.area. According to the SPL convention, getting a field from a record sequence is equivalent to getting a field from its first member. Sometimes, even if we want to get an aggregation result of the group subset, it is not easy to calculate, and there is no simple aggregation function to use. In this case, we also need to keep the grouped subsets for further calculation. For example, we want to group the personnel table by gender, concatenate the names of people of the same gender into a comma-separated string. This is indeed an aggregation result, but SPL does not have such an aggregation function. It can be written with an expression. Just do new for the subset sequence after grouping. This operation is common. SPL also allows it to be simplified into the parameters of the group function. Note that this is easily confused with groups. The calculation after the semicolon of group is equivalent to a simplified new, and we need to write tilde to represent a group subset. But we don't need to write tilde in groups. In fact, its calculation method is different. It does not calculate the subset first and then calculate the summary value. As mentioned earlier, there are 5 common aggregate operations. SPL also provides other aggregate functions that can be used in grouping and aggregation, but most of them do not need to be specifically mentioned. You can check the documents when necessary. There is only one iCount function to mention here. iCount x returns the number of distinct values of x in each group. This is roughly equivalent to another grouping in the group, but the inner grouping only counts and does not do other summaries. For example, we want to calculate how many companies each area has done business with. If you understand the iterative function mentioned earlier, SPL also allows you to spell out new grouping and summary operations. Moreover, after fully understanding the iterative function, you will also realize that groups and group use different methods in calculating the summary value. Groups use the iterative function method to calculate the summary value, and each grouping subset will not be maintained in the process, which will be more efficient and use less memory. This is also the main reason why groups is designed separately. In addition, grouping operation is not only valid for structured data, but also for numerical or string sequences. A1 will group integers by parity and calculate the sum of each group. A2 divides the file names under the path into several groups according to the extension. However, grouping for sequences is relatively uncommon, so we talk about this operation in the structured data section. Section 2. Enumeration and alignment. Members with equal grouping keys are divided into a group, which is called equivalence grouping. Equivalence grouping meets two characteristics. 1. All members of the original set are in and only in a unique group. 2. No group is empty. Grouping satisfying these characteristics is also called complete partition in mathematics. Then is there an incomplete partition? Yes, the two requirements of complete partition may not be satisfied. For example, there may be an empty subset in the result, or some members of the original set may not be in any group or in multiple groups. In this section, we will talk about this kind of grouping. We have made statistics on grouping personnel table by gender. Generally speaking, we expect the return table sequence to have two records, that is, one for male and one for female, and even ensure the order, so that we can know exactly which record to use to obtain the summary result of male or female. However, equivalence grouping cannot guarantee this result, because there are not necessarily two genders in this personnel table. If there is only one gender, there is only one record in the return table sequence. In this case, we must compare again to know whether this record is male or female. This is very inconvenient. We want to make sure that there are two records returned, and the order is also determined. If there is only one gender in the data to be grouped, let the summary value of the other gender be 0. This kind of grouping is called alignment grouping. It is not completely divided because empty set may appear. Before alignment grouping, there need to be a criterion sequence, such as A2 here. The align at A function in A3 divides the set to be grouped, such as A1 here, into several subsets, and the grouping key of each subset corresponds to the criterion sequence members one by one, that is, the records with the same grouping key value as the criterion sequence member are divided into the same group, so that the number and order of the obtained grouping subsets are determined by the criterion sequence. If a criterion sequence member does not correspond to the grouping key value of any sequence member to be grouped, it will correspond to an empty subset. With a grouped subset sequence, it is very easy to calculate the table sequence composed of grouping key values and summary values. Note that for the new function in A4, A2 hash should be used to obtain the grouping key value, because some grouped subset may be empty and this information cannot be obtained from the grouped subsets. SPL only provides the method of generating grouped subsets, and does not further provide simplified functions to calculate the summary values at one time. On the one hand, it is not difficult to write. On the other hand, alignment grouping is less commonly used than equivalence grouping. Let's take another example. In the previous order data, we want to calculate the sales amount by month in the last 2 years, regardless of whether there are no orders in a certain month or not. In this grouping, not only empty sets may appear, but also some records of the original set may not be divided into any subset, such as those orders that are not in the past 2 years. Careful readers may find that the align function has an option at A, so what is the operation when there is no option? It is used for sorting. Similar to alignment grouping, we sometimes need to arrange a batch of data in the order we want, rather than the conventional alphabetic or coding order. In this order table, we want to calculate sales amount by region, but the results should be arranged in the order of east, west, north, south, center. Of course, we can use align at A that we just learned. If we know for certain that there is at most one item in each group, we can write it in another way. In the table sequence obtained after group aggregation in A3, there is at most one record in each region. The align function without option can rearrange these records in A2 order. Aligned sorting is more common than alignment grouping. People have many conventional fixed sorting orders. For example, China's provincial rankings usually rank Beijing first, rather than Anhui first according to the Unicode order. Americans do not have such a fixed notion of sorting regions, but they also have conventions such as Sunday, Monday, Tuesday, and low, medium, high, that cannot be sorted directly in alphabetic order. There is also a very common alignment grouping. The grouping key values are positive integers starting from 1, and the target order is to arrange the numbers from small to large. For example, the months are numbers 1 to 12, and weekdays are also integers of 1 to 7. This situation is also called serial number grouping. SPL provides an option at end to support serial number grouping in the group and groups functions. When used, it is very similar to groups without at n, but it is an alignment grouping, allowing the generation of empty sets. If the grouping key value is less than 1, it will also be discarded. Try the stock data we generated earlier. The table sequence returned by A3 will have 6 records, of which the first one corresponds to the group subset of Sunday is an empty set and its grouping key value should be 1 because the data of Sunday has been filtered out in A2, and the largest grouping key value in the remaining data is 6 since Saturday data has been filtered out and 7 cannot be calculated out, so the result table sequence has 6 records. The first record corresponds to an empty group subset, and both aggregation fields are null, but the grouping key value field still has a value. The grouping key value here does not decrease by 1, and will be 2, 3, 4, 5, 6, corresponding to Monday to Friday, which is different from the previous calculation result. We can also change this to subtract 1 from the grouping key. Only Saturday data is filtered out in A2, and the grouping key value is subtracted by 1 when grouping in A3, thus the grouping key value of Sunday data will be calculated as 0 and discarded. A3 will calculate 5 records without Saturday data, the maximum is 5, and this is the same result as before. It can be seen from these two examples that serial number grouping is not an ordinary grouping with serial number as the grouping key value. Its behavior is more like alignment grouping. Empty sets may appear and members without corresponding grouping subset will be discarded. The effect of using at n for group function is similar to that of groups function, and we won't elaborate here. Another advantage of serial number grouping is fast calculation speed, because the correct grouping subset can be found directly with serial number without comparison operation. In addition to regular alignment grouping, conditional grouping will also occur, and the most common is grouping by segment. For example, people are divided into several groups according to age, or orders are divided into different groups according to amount. For example, we divide the previous personnel table into 4 groups according to BMI value, less than 20, underweight, 20 to 25, normal, 25 to 30, overweight, greater than 30, obesity. Then calculate the average height of each group. The conditions of different levels are written into strings to form a sequence, in which the question mark represents the grouping key value to be substituted into the calculation. The enum function will use the grouping key of each member in the set to be grouped to calculate these conditions in turn. If it gets true, the member will be divided into the corresponding group. The final grouping subsets will also correspond to these criterion conditions in quantity and order. This grouping is called enumeration grouping. Obviously, enumeration grouping may also get empty sets, and some members may not be divided into any groups. Similarly, SPL only provides the enum function to return the group subsets. To get the summary value, we need to further calculate it ourselves. Unlike alignment grouping, enumeration grouping usually has another sequence to identify the name of each group like A3 here. Because segment grouping is very common, this case can also be converted into serial number grouping with the pseg function described earlier, which is simpler to write and faster to execute. Group at n is used here to calculate the group subsets first. Because the pseg function will return 0 for the case that is less than the first member, it needs to add 1 as the grouping key value, otherwise this segment will be discarded. It is also okay to calculate the summary value directly with groups function, but we need another step to fill in the segment ID correctly, otherwise we will see the grouping key value itself, that is, 1, 2, 3, etc. In fact, alignment grouping can be regarded as a special enumeration grouping. All alignment grouping can be written by enumeration grouping. The enum function also supports repeated grouping, that is, a member may be divided into multiple grouping subsets, but we won't talk about it because it is less common. You can use help when necessary. SQL has only equivalence grouping, and it is very troublesome when encountering the calculation requirements of the enumeration grouping, including alignment grouping. Section 3. Order-related grouping. As we said, record sequences and sequences are ordered, and the positioning information of members often participates in the calculation. Grouping is no exception, and grouping keys may also be related to sequence numbers of members. For example, we want to divide the personnel table into groups of every 3 records. The grouping in A2 does not use any information of records in A1, but only the sequence number, which is also a reasonable and even common grouping. After all, the essence of grouping is to split a large set into small sets. As long as there is a clear splitting method, it is reasonable. To divide the personnel table into 3 groups, we can use the step function mentioned before or directly use group. By the way, the grouping key values of these 2 examples are integers. We can also modify the serial number grouping mentioned earlier, and it needs to ensure that the grouping key value is a natural number starting from 1. In addition to directly using the sequence number as the grouping key value, the grouping may also be related to adjacent members. For example, given a string composed of letters and numbers, it should be split into consecutive letters and numbers. The group@O function will scan the whole sequence in turn. When the grouping key value is the same as that of the previous member, the member will be added to the current grouping subset. If the grouping key value changes, a new grouping subset will be generated and the current member will be added to it. After scanning, a batch of grouping subsets will be obtained to complete the grouping operation. Is_digit x returns true when x is a numeric character, otherwise false. We have learned A1.split and it will split this string into a sequence of single characters. Thus, the grouping key value expression is_digit tilde will be calculated successively for this single character sequence as false, 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 true, 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 false, etc. That is, it is false when encountering a letter and true when encountering a number. Changing from number to letter or from letter to number will cause is_digit tilde to change, resulting in a new grouping subset, so the return value of group@O will be. That is, divide the adjacent letters or numbers into a group, and then use concat to concatenate each group into a string. This grouping is difficult to describe with the grouping operation we learned earlier. This is another example of doing grouping directly to a sequence. If we know that the grouping key value itself is orderly, the ordinary equivalence grouping can also be done with @O. For example, if the order data is orderly by date, and we want to group and summarize it by month, we can write this. @O also works for groups function. There is no difference in the result whether we use @O or not here, but if we use @O when the data is orderly, groups function only need to compare the grouping key value with adjacent member, and the calculation speed is much faster. @O has another variant @I, with which the grouping key is a logical expression, and a new grouping subset is generated whenever true is calculated out. Let's review the previous problem of calculating the maximum consecutive days of stock rise. Another way of thinking is to sort the transaction data by date, and then scan these data in turn for grouping. If the price of one day is higher than that of the previous day, it will continue to be divided into the same group as that of the previous day. If there is no rise, a new group is generated. After scanning, we will get some subsets. In each subset, the stock price rises continuously. Then we just need to see which subset has the most members. By the way, the easiest way for SQL to complete this task is also to use this idea, but the code is like this. You can feel the difference. The grouping operation that needs to use order and position information is called order-related grouping. Order-related grouping is very useful in parsing text. Some text files are not in very neat text or CSV format, but have regular text strings, in which there will be structured data which needs to be parsed by programming if it needs to be reused, such as the text in the figure. Generally speaking, a batch of events will be described in a log, and each event will occupy several lines of text. Structure analysis is to extract the field values of each event. Using order-related grouping, these log texts can be easily divided into small segments with events as units. The log is usually divided into events in several ways. 1. Each n line corresponds to an event, which can be split by group #1\n. 2. The number of lines is not fixed. There will be a fixed starting string before each event, which can be split with group @I. 3. The number of lines is not fixed. Each line of the same event has the same prefix, such as the user ID of the log, which can be used split with group @O. After splitting, the code can concentrate on parsing the field values from the string of each segment. Of course, this is usually not a simple task. Section 4. Expansion and transpose. After grouping and then summarizing, we usually get a smaller set than the original set, which is equivalent to aggregation. Then, is there an inverse operation of grouping, using a smaller data table to calculate a larger data table through some rules? We call this kind of operation expansion or inverse grouping. However, the summarized data generally has lost the detailed information, and the reverse calculation cannot be realized. Explicit expansion rules are required for expansion operations. The table sequence contains loan information of some customers, including loan periods and amounts. Now we need to calculate the monthly repayment amount of these people according to the equal principal and interest method, and the interest rate is a constant. The news function in A2 will generate number records for each member of A1. The field name and calculation formula are described by the following parameters. The calculation formula of this installment loan is copied online. It's not the point. Think about the hash in the parameters. The news function is essentially a two-layer loop function. First, it loops through the members of A1, and then it loops through the first parameter number. The parameters after the semicolon are actually for the inner loop function, that is, hashes for the number layer, i.e., the number of loans, not the member of A1. The calculation amount of this code is a little large. Because the monthly repayment amount is actually the same in the equal principal and interest method, there is no need to calculate it so many times. Just calculate it once for each A1 member. Note that A1.hash is used here to refer to the sequence number of the outer loop function. Let's implement the inverse operation of string merging in the previous section. A3 will split the string concatenated in A2 and expand it into records with the same number of rows as A1. Again, news is essentially a two-layer loop function. The sex in the parameters is the field of the outer loop function. Because this field cannot be found in the inner layer, SBL will automatically find it in the outer layer, so we don't have to write A2.sex. And tilde is the current member of the inner loop function, i.e., the name after splitting. There is also a more common expansion operation, expand the columns of the data table into rows. We need to use the student score table we used before. A3 will generate a data table with 6 fields. Except for the ID field, the others are all the score of one subject. When we talked about the concept of structured data, we mentioned that since these subjects are of equal status, statistics on these subjects, or scores, may occur. Therefore, the more common data structure will be 3 fields, ID, subject, score. Now the field name of the data table will become the field value of the subject field of the new data table, and each record of the original table will become 5 records of the new table since there are 5 subjects, which leads to expansion operation. We can write it with news function. A4 lists all subject fields, and A5 performs the expansion operation. Note the 2 tildes in A3.tilde.field tilde. The former is A3.tilde, i.e., the current record of A3, that is, the record being expanded, and the latter tilde is A4, i.e., a subject field. Now A5 becomes such a data structure. This kind of operation is very common, and SBL provides a special function to handle it. For this case where all fields except ID need to be expanded, it can be further simplified as. Careful readers may find that the pivot function uses an @r option, so what will be calculated without the @r option? When there is no @r, it is its inverse operation, which is equivalent to grouping. We will find that A5 becomes A3 again, but the field order has changed, and the subject fields are arranged in alphabetical order. However, there is no problem with the data. If we want to follow the original field order, we need to write the field list into the parameter. Concat plus at Q means to spell additional quotation marks, and it will be explained later. Pivot function is also called transpose operation, and with it R it is called inverse transpose. Transpose is a variant of grouping operation, which can also be realized by grouping. It can be seen that A6 here also changes back to A3, the subject fields are also sorted. If the original order is to be used, replace A5 with A1 in the A6 expression. The macro in A6 expression is complex, but it can be understood through careful study, that is, take the score with the same subject name in the current grouping subset as the value of the subject field in the table sequence after grouping. Because the subject is a string in A4 and the grouping subset is composed of records in A4, quotation marks should also be added during comparison. The same principle is used in the previous code using pivot, so the @q option should be added in concat. This syntax is really troublesome, so SPL provides the pivot function to directly implement this grouping and summary. In other words, transpose is just a grouping and summary operation. Accordingly, inverse transpose is the expansion operation. It should be emphasized that this transpose is different from the transpose in Excel. The transpose in Excel is equivalent to the transpose of matrix, which is a simple row-column exchange, that is, row to column, and column to row. The transpose here is actually a pivot in multidimensional analysis. It is an extended variant of grouping operation. Inverse transpose is a variant of inverse grouping. Usually, a field is used as a grouping key, and this field is stable and will not be transferred into a column. Transpose is actually a common saying that refers to pivot in the context of this book. However, the transpose of SPL is slightly different from the ordinary grouping. As can be seen from the expression of A6, it will not aggregate the grouping subset, but simply get the first item. In fact, this operation assumes that there is only one record or none in each grouping subset after filtering with the field name of the target table. If there are multiple records at this time, which is possible theoretically, the pivot function has no place to describe how to aggregate these records. A better way is to do a round of group aggregation in advance, and then do the pivot function. The table sequence we generated in A2 has duplicate ID and subject, so that the grouping subset will have multiple records after being filtered by the field name during pivot. Direct pivot may not get the desired result. A round of group aggregation needs to be done first, and then pivot. If the aggregation method of all fields is the same, it can also be simplified as A6. The option at S indicates that one more step of aggregation is required, and the aggregate function is written in the parameter. If it is different, for example, some calculate sum and some calculate max, we can only do the aggregation of A4 first. It is very convenient to use the pivot function without the third segment parameter, but some desired fields in the result table sequence may not be generated due to the lack of data. A3 filters out the out subject and then do pivot. The result will be one less column, and there will be no out subject. To forcibly list all subjects according to A5, the corresponding values of the field with missing data in the result table sequence will be filled with null.